I will talk about wind energy systems, but before we start, I want to introduce you to artificial intelligence. Sounds a little bit too science fiction. So, artificial intelligence is nothing else, just a branch of computational science that knows how to create intelligent agent. Intelligent agent is something or a system that takes information from outside, digest it, and get the output result. Nothing too complicated here. The best known intelligent agent is, of course, the human brain. It's natural intelligent agent. We get impulse signals from everywhere, think about it, and we're doing our forecasting. And based on this forecast, we make a decision. Normally, we succeed very well. This is an example of the brain of the person who likes sailing. He's looking on the window in the evening and just thinking, okay, this is the sunset I have. Depending on how much clouds I have, what the color of the sky, what do we have there general, he can forecast whether it will be a wind tomorrow or it will be still, and then making a decision would it be a good sail tomorrow or not so good. And I think scientists have been thrilled by human brain, and then just looking at the brain structure, trying to do something like that, they find out that the brain is nothing else, just a big network of interconnected neurons. So they try to mimic the structure with hope to get the same result. Surprisingly, they succeeded. This is well-known intelligent agent, so-called artificial neural network. It consists of layers or input where we can put the input data, signals coming from one layer, then somehow digest it inside the hidden layer and give out the output information. All units are interconnected with so-called weight. It's a little bit of mathematics. Then comes the wind. This is a project. We have few wind turbines. We invested a lot of money into it, and we forecasted the wind, and we expect the planned output. Then the actual output came out, and we're a little bit sad. It's not exactly what we want. Why it is so? Most likely because we didn't count on a lot of factors. There is a wake turbulence, there is a wind reduction, depends on where the wind farm located, etc., etc. A climate change in those years, so we get the good result today, maybe not so good tomorrow. Weather can change suddenly or depends on the season. Each of these problems is very complicated, and for physics it takes hours, at least hours, to calculate each of these events. But what if we do something with artificial intelligence that can just learn from the presented models? So there was an idea to do a wind farm optimization, model large offshore wind farm where consists of hundreds of turbines. We need our model to take into account all this turbulence, all these wind sudden changes, etc., yet to be time efficient. We're looking around, we have a good support from our colleagues abroad. When they actually started a wind park, picked two turbines, and one on the first row, one somewhere in the middle with the high turbulence, and said that the great advantage of a neural network was demonstrated. You can teach the network artificially what it is like working in a turbulent condition, and your prediction would be very accurate. We come a little bit further than that, and we're thinking, what if we will see the wind farm as a set of clusters? Different clusters consist of different wind turbines, and each wind turbine will be assigned to the cluster. Depends on what kind of wind we have. This wind coming from the southwest. This is the first row wind turbine, no turbulence here. This is the second row wind turbine working in a high turbulence event. Wind suddenly changes. Cluster reassigned. Okay, that would be good. Instead of calculating tens of turbines, All we have to do here is just to calculate output for one turbine with no turbulence and one turbine within turbulence, and then just add the results. Shall be faster. Then it's a question how fast it will be to assign these clusters. Let's ask neural network. This is the model of the wind park. 36 turbines here, and the neural network represented here. It's been asked to assign the clusters. Depends on the wind. That's good. This is neural network. It is thinking at the moment. OK, I'm very happy to say it assigns something, but we cannot see the result. Anyway, it took only 10 seconds for neural network to assign all the clusters for 36 wind turbines. And it divided the entire wind field into the wind farm into 4 clusters. So instead of calculating output for 36 wind turbines, we have to calculate something for 4. 9 times efficient, more efficient. I think it's not so bad. OK, with this clustering approach, we can do energy output forecasting and do it not only efficient as a traditional method, but do it 9 times faster. We can do site and layout evaluation for the wind farms, and we can do it even for the turbulent areas with no problem, because we know our neural network can be trained to work on a turbulent condition. And we can do nowcasting, which is very important for wind farms, and because we know the current weather. And our clustering model allows us to tell what this particular wind turbine will see in a bit, depending on where it is located. This is what we're doing at the moment. And to the end, just to share a dream. Why don't we go from the smart turbines to the smart parks? It is not so hard to introduce the wind turbine that not only taking into account the weather condition, but also the neighboring wind turbine condition. And then they working cooperatively, so the output of the wind park would be always maximized. Sometimes it might come to the strange decision that the first row turbine can shut down itself just to let the wind go through it and allow 3 behind it turbines to take the full wind, if it will promote the entire wind park output. So this is a dream, something we want to do. Thank you.